Assalamu alaikum guys. Welcome to Sales Data Analysis Project tutorial. In this tutorial, we are going to perform analysis on sales data. So let's say our e-commerce sites such as Amazon, Flipkart, eBay, and all the different are approximately selling lakhs of product within a minute. So just try to think how much huge amount of data these companies are creating. Let's say a customer that is going to buy a product that will of course have some already product name and quantity and product id of their product that he has purchased, the price of the product, and at what address. Basically the person is going to receive that order, so that uh, type of data the person is going to be produced. So now you have to analyze this data. So what type of analysis you can perform? So let's see what kind of analysis we can perform in this dataset. Okay. So here we can analyze the high month in which the sale is maximum. Okay. So from this visualization, we can see that October, November, December, these 3 months contain the maximum sales. Okay, this is showing the highest sales. Okay, so and if we consider cities, so we can find the San Francisco. In San Francisco the sales is maximum. Okay, so similarly, if we analyze which product sold the most and why, analyze which product sold the most and why, we can find two different visualization, where first one we can find the product that sold the most, like here AAA batteries product sold the most. Okay, and in second visualization we can create a correlation between sold and the price and the quantity. We can see here that the maximum the quantity sold, the minimum the price is. Okay, so and next we can analyze what time should we display advertisement to maximize for product purchases. After analyzing this chart or visualization, we can conclude that between 12 p.m. and 7 p.m. or 19 p.m. Okay, or 7 p.m. Is equivalent 7 p.m. Okay, so between 12 p.m. and 7 p.m., the perfect time, this is the perfect time to display advertisements to maximize for product purchases, because in that time product purchases, the number of product purchases is maximum. So this is the perfect time to display advertisements. And finally, we can simply analyze the most sold products, that the products that are sold together. Okay, so here we can see that iPhone and lighting charging cable, uh, and Google phone USB-C charging cable. These are the combination of product that sold the most. Okay, so this is all that we are going to do in our or we are going to perform in our upcoming analysis. Okay, in this tutorial. So without wasting time, let's move into our code. So so our first task is going to prepare our data for the analysis. So for this, first let's create a file called sales analysis dot ipynb or ipython notebook. Okay, and okay, first let's import the necessary libraries. Let's import first I import OS, and then let's import pandas spd, and then import uh, matplotlib for our visualization purpose dot pyplot splt, and then let's import seaborn. This is also a visualization tool as sns. Okay, so now let's execute this line of code, and I will select Python environment, and then okay, recommended version. And now uh, according to our objectives, like we need to first prepare our data for our analysis purpose. So here our all the data set, like this here are almost 12-month sales data set, right? Here April, August, December, February, January, July, June. So there are almost 1 year or exactly 1 year's data of sales. Okay, so I will merge all of them uh, by using. Okay, so I'll first using operating system or OS. I will uh, extract them for. Okay, using operating system will uh, use merge this. Okay, using operating system or OS, we will merge all these 12-month sales data. Okay, so we'll use os.list directory, and we'll pass a location or a path, okay, as an argument here. So let's copy the path and paste it here. So now execute this line of code. So we are getting a list of all our CSV file. Okay, all of the data set. Okay, so now let's store this value or result into a variable called files. Okay, okay, so again execute this line of code. Okay, now we're going to merge 12 month sales data into one CSV file. Okay, before I doing this, first let's create a empty blank data frame called um, all data. Okay, pd dot data frame. Okay, and then store path into separate variable. Let's copy the path of this folder. Okay, and then paste it here. Okay, so we just copied location into a path variable. Okay, so now we'll perform iteration using for loop. So uh, I'll use for file in files. Okay, then I'll use a current df or data frame pd dot read csv, pd dot read csv. Then I'll give parameter called path. Okay, as path, and then forward slash. Okay, and then I'm going to give our file name. Okay, so this line of code just simply um, extract the CSV file. Okay, uh, by using this location. Okay, or accessing this location. So and store the data frame into current df. Okay, so we are just going to merge or concat this current data frame with our the root data frame. Okay, or the main data frame. So we just simply will use concatenation. So pd dot concat, and here we'll be using our all data. Okay, the root data frame with the current data frame. So every time a new data frame is been created, okay, that will automatically merge or concate with by this concate function with our previous or the main data frame. Okay, so this is how we merge our 12 this 12-month sales data. Okay, So the moment we'll execute this line of code, let's see what we have get. So all data dot head. So I'm going to get top or first 5 data. Okay, first 5 rows. So this is our data frame ultimately, or after merging the 12 months sales data. Okay, so we can see there are none or not a number or null values. Okay, so we need to perform data cleaning and data preprocessing. So now we'll check for non values or null values into our data frame. So all underscore data dot is null. Okay, and dot sum, and then now we get the information like there are 1090, almost 100 1100 data are missing, or there are something abnormal with this data. Okay, so we'll just simply drop the uh, abnormal data. So drop null using drop null function, drop null, and here I'll use a parameter called how, and I'll set this parameter as all. So now let's check. Okay, now again execute, copy this line of code, and now paste it here, and now execute. Let's check for if there are null values now. So there are 0 abnormal data, okay, in our into our data frame. So now we're going to check the data types of our data frame. Okay, of different features. uh, Sorry, series object that d types or returns a series object. Okay, and that is not callable, so we cannot use here this parenthesis. Okay, now execute this line of code. We are saying that uh, order id is object, product object, and so almost every feature is object. Okay, so but this is not right, because order id cannot be object, as well as price and order date is date and time. Okay, the data type should be date and time, and then quantity ordered also should be integer type, and price should be like float type. Okay, so we'll change the data type as per need our visualization purpose. So we'll just leave it as here. So we'll just leave it as default. We'll change it future when we'll analyze it, when we'll be working with these features. Okay, for analyzing purpose. Okay, so now I'm going to simply save this data frame, or convert this data frame into a dataset or CSV file. So I'm going to use our data frame and use to CSV, and then I'll give our name after that will be used after converting into CSV file. Okay, so I'll give all data, all underscore data dot CSV. Okay, so and I'll set index as false. So in our dataset, index will not be uh, applicable. Okay, so index will not be visible. Okay, so execute this line of code, and here is our dataset after converting it. Okay, from data frame. here in this data set we just merged all the 12 month sales data. Okay, so this is our this called like merged data set. Okay, that contain this 12 months sales data. So this will need into in our future analysis. Okay, now mm, let's check the shape of our data frame. So we have this row and this six feature or columns, okay, into our data frame. Okay, now I think we almost complete or prepared our data uh, after data cleaning and pre-processing for further analysis. So now let's check our objectives. So we have successfully completed our first task. Our second task is going to be analyzing the best month for sale. Okay, so we need to find out the best month for sale. Okay, now let's look into our data frame again. We are going to say call our head function. Okay, okay, head to get the top first 5 row. So this order date feature will be needed in this objective. So because this feature contain month, days and year. Okay, so we need to extract month from this feature, and then uh, we need to analyze sale. Okay, for and which month um, have the best sale. So we need to find out that month. Okay, that for example use this first data. Okay, let's see how to extract a month, okay, from this data. So to simply use split function will split here this delimiter. Okay, this will split this text or this object by this delimiter. Now let's see what we will get. We get this we get a list. Okay, by breaking down this text into three file or three index. uh, we can see that this forward slash divided this text into three part: month, days and like year. Okay, okay, so if we want to get access the month, so we'll simply place 0 here because we want to get access of 0th index or first element. Okay, now this is month. So now simply we'll make a function to so that we can get month from all the rows, okay, or all the data similarly like this one. Okay, so let's create a function called month, which will take a parameter. Let's say uh, m. Okay, and which will return say sorry let's say date. Okay, and which will return date dot split. Okay, then delimiter this will be, and we'll get access the first element. Okay, this will be returned. So let's execute this line of code, and now uh, we'll be will be using a conditional formatting. Okay, so by using apply function for this let's say all data. Okay, and all data say date or order date. Okay, so dot apply say apply function. This is called conditional formatting. Okay, so we'll use apply here. This apply function and we'll use we'll simply this send this parameter, okay, this or order date feature in month function as a parameter. Okay, so this is just is this whole thing is done by apply function, and this is also called conditional formatting, because here this apply function simply uh, pass this feature of this data frame, all data, okay, data frame, uh, uh, pass this feature uh, in this functions parameter, okay, month. Okay, so if we execute this line of code, I will simply get the all of the month, okay, of the data frame, or of the all of the data. Okay, so we'll store this data or value or month in another column. Let's say we'll name this column as month. Okay, so now this will create a new column named month. Okay, so if we now call head, or we want to see, let's say first top element, then all data dot head, and here we can see our newly created month column. uh, there are okay, there are this is month, okay, 4 4. Okay, so now let's check their data type. So all data dot d type. uh, so okay, here month is object, but month must be integer. Okay, so let's change its data type by uh, okay, by s type function. Okay, so all data say month, and equal all data month, uh, okay, all data month, and dot s type integer. Let's integer. Now let's check. Unfortunately we got an error. It is saying that invalid literal for integer we placed in order date. Okay, if we say month all data dot unique data, say month, we want to access, and now let's say all the unique value of month column. Okay, so here you can see order date is an element in this month feature, which cannot be converted or inverted into integer. That's why we are getting this error, invalid literal for integer. Okay, we guessed in. So we need to uh, remove this element, okay, from the feature, because this cannot be converted into integer type. Oh no, um, okay, again করতে হবে. Okay, now we just simply need to remove this order date, okay, element or entity from this feature. Okay, so for this, now simply apply a condition where we'll find the order date entity in our this feature. How? let's say let's see, we'll apply a condition where we'll check for month that are equal to the order date, this entity, okay, order date, and we'll store this filter or into, okay, we'll store this filter into let's say filter variable. Now we'll remove this filter or the uh, this value, the value or the rows that are where the month is equal to the order date. Okay, so we'll use tilted sign here to remove uh, the selected filters, okay, or the selected rows and that are stored in this filter variable. So we'll, by using tilted sign and then use filter, uh, this line will remove, okay, this the all the rows where month is equal to order date, and to store the save the changes or store the ultimate result into our data frame. We'll use all data and, okay, store this output into our all data frame. Now the moment we'll execute this line of code and let's see the output. I'll copy this line of code and paste it here, and now see there are no order date in entity. Okay, so we can now we can change the data type. Simply copy this line of code and paste it here. Now see, this is successfully converted. Okay, so now again if we check for our, let's say, data types of our different features, you can see month is converted into integer type. Okay, so now we need to convert also price, uh, which is now currently in object, but we need to change it into float, and then quantity ordered into integer. So now let's work for them. Now select all data and price uh, each, and then dot let's say s type. Okay, float float 64, float 64. Okay, and we'll say save the changes. It's all underscore data, let's price each. Okay, okay, assign this uh, into, okay, will this line will save now. Okay, now execute this line of code, and then our next target is going to change the data type of quantity ordered. So simply use all data or data frame and quantity ordered, and then again to convert this data type quantity ordered, quantity uh, quantity ordered. Okay, then use fs type, then integer. Okay, now execute this line of code. Now again check for the all the types. And okay, now we get our ultimate features. Okay, that month is converted into integer and price converted into float, and product or quantity ordered into integer object. Okay, okay, now if we go back into our objectives, we can see uh, objective is looking for sale. Okay, best month for sale. Okay, so we need to, now we need to work for sale, so we need to find out sale for each month. Okay, so for this we'll simply first create a feature column, and then name this sale, and which will be the result of the multiplication of quantity ordered and the price of each quantity. So simply we'll multiply ordered quantity or quantity ordered into multiplied by multiplied with all data, and the price. Okay, price each. Okay, so now uh, let's check uh, let's check for head. Here, this is our monthly sales. Okay, sale for each month. Okay, now uh, to find the best month, okay, for sale, now we need to use a group by function. Okay, so using group by function will simply group all the month. Okay, and their according to their sales. Okay, so for, from this we can compare the best month or the sale, in which month the sale is maximum. So now apply, uh, let's say all data but group by. We'll simply use group by function. I'll call a group by function, then use a month because we want to group month. Okay, then our and we want to uh, take sale. Okay, and then here we need to use an aggregated function here. So we'll use sum function because we simply can see that here for month of 4. Okay, the number of fourth month, or April. Okay, April month has different quantity or different number of sales. So group by method will simply just group all of these month, that is the number of 4 or April month, will group this, and the the sales uh, with respect to each month, okay, will be sum, or will be aggregated as summation. Okay, uh, beside this group by month. So the moment we'll execute this line of code, we'll get the ultimate results. Here for first month, we get the all sales for the first month, okay, of the sum. So the sales are uh, coming out this as sum. Okay, the result of this sales uh, calculated by sum, not like multiplication or any other thing. So because we give aggregated function sum. Okay, so this is this will be needed in our into our visualization. Okay, yes, so store this. I will simply store this variable as sales, monthly sales. Okay, monthly sales. Okay, and again execute this line of code, and then uh, and now I will plot this. I will plot a bar chart. Okay, and which will be showing monthly sales in x-axis, and sorry, monthly sales in y-axis, and the months, number of months, okay, in to x-axis. So for this I need to uh, create our x-axis, which is will be month, uh, and that will be months of like 12. Okay, 12 months. So we need to, so here we need to use range and 1 to 13. So it simply return the 12 months. Okay, which will be needed into our to use our x-axis. So and then use simply plt from matplotlib, plt.bar. I'll use months as x-axis. Okay, and monthly sales as y-axis. Okay, now then I'll use plt dollar. I'll give a x label. Okay, as month. Okay, and then I'll give a y label which will be sales in USD. Okay, and I want to show the visualization. So let's execute this line of code. And now, okay, so we are getting monthly. We have just successfully implemented this objective, the main best month for sale. So from this visualization we can simply easily find the best month for sale. So because this, if we analyze this visualization, okay, we can see that the December month or the 12th month is getting the maximum sale. Okay, so in December month the sale is maximum, so this is the best month for sales. Okay, so this is so easy for uh, analyzing. uh, uh, if we wanted to, and also here if we wanted to uh, see all the like months, okay, not 2 4 6 8. If you want to see 1 2 3 4 like this, so just simply we can simply add a plt.xtics here and set the parameter as months. Okay, okay, now execute this line of code and see uh, our expected output. Okay, so this is first month of January, February, and followed by uh, December. So this is our monthly sales, best month for sale analysis. Okay, now moving into our next objective. So look for our next objective, which is saying to find the city which has a maximum order. Okay, okay, so now let's look into our dataset again. Let's see head, or first 5 elements, or first 5 row. So to find the city we need to deal with this feature. Okay, so we need to find out or we need to extract the city name from this address. Okay, this address of text. So we'll use here split function and we'll uh, provide a delimiter comma. Now let's see. So this text or address splitted into 3 parts. So this is in the this middle part is our required data. Okay, so to access this data we'll simply give index 1. Okay, so this is what we wanted to extract. So now we'll be using a function to extract all of the cities from this feature. Okay, like this one. So let's define a function called def city. Okay, then provide a parameter, let's say city name. Okay, and then which will be returned uh, uh, all data. No, okay, so this city name will be text. Okay, will be text like this one or this one. Okay, so we need to just simply use city name dot split, and we'll need to provide delimiter comma, and this text will split into 3 parts by this comma. Okay, and then we will access we'll get access the city name by this index 1. Okay, so let's execute this line of code, and now we'll be creating a new column by using conditional formatting, by applying conditional formatting. Okay, so how, let's see. We want to add create a new column all underscore data in this data frame, and we need to let's name the new column like city. Okay, and then assignment parameter or assignment operator, sorry. And now we'll apply conditional formatting on this feature, city or this purchase address. Okay, so copy this column name here, and so now we'll apply use of apply function. Okay, and here we'll pass our city function, city method. Okay, this method. So this line of code just simply do this, what that the each text, okay, or each data as will go through as parameter like city name in this function. Okay, so let's execute this line and let's look into our data frame. Let's look into top 5 okay, first 5 rows. So here city column has been created. Okay, and this column contain all the city name of this uh, okay, from this address. So now now we'll apply a group by function. Okay, we'll call group by because we need to group by the cities and the order that respect to the each of the city. Okay, so now let's have all data dot group by, and we'll group by cities, and we'll count the city name. Okay, and we'll count the city name to get the number of orders from each city. Okay, and dot we like use aggregate function count. So this is our complete line of code. So let's execute this line of code, and this is our output. Okay, now we'll plot this data. Okay, we'll plot the city versus the number of orders. Okay, so this is okay, so in this left side this is city, okay, name, and in the right side this data means the total orders of each city. Okay, so uh, okay, so before going into visualization, store this data, store this value into, let's say, y. Okay, because I am going to plot this data into y-axis. Okay, this value. Okay, so now let's plot uh, let's say use this code. Okay, now let's use Matplotlib PLT. Okay, so now use a PLT from. Okay, so now use PLT from Matplotlib PLT dot bar, where first we need to provide the axis information. So I'll I will put the city name, okay, in x-axis. So I need to say y dot index. Okay, since this is a series, okay, this is a Pandas series, so this left side means index and this right side means the value, okay, of this each index. So this is the um, formation of a data Pandas series. So if we want to access this city name, so we need to use dot index function. Okay, so this will be provided into x-axis, and now I will provide this data or value into y-axis. Okay, now let's say plt dot x label. Okay, and name this label as city, and plt dot y label, name the y-axis label received order. received order, and PLT ultimately uses oh, and ultimately PLT dot show to display our visualization. Okay, so we need to execute this line of code first, and then let's execute this. So here we need to change. We see that there are little this x-axis information is saying little bit messy, so we need to fix this. For this, let's use plt.xtix, and the rotation will be vertical. Now, okay, so this is our final visualization. So from this visualization, we can analyze the data of city. We can find which city has maximum order. So according to this visualization, it is saying that San Francisco has the maximum has received the maximum orders. Okay, so this city has maximum orders, and followed by Los Angeles, New York City, and others. Okay, so this is really easy to find the city with largest or maximum orders. Okay, first let's check our okay, so we need to extract this hour component. Okay, so this is the hour component 846, and then groups the data by hour to count the number of orders made at each hour of the day. Okay, and this information can be used to determine the best time to display advertisement to maximize product purchases that will meet this objective. Okay, so let's work for this. Now let me write a block of code. Let's say data order date. Let's first check the data type. So this is showing the data type is object, but we need to work with datetime object. Okay, or datetime data type. So need to change to pd dot to datetime, then all data, and give the feature name or column name here, and then datetime dt dot hour to extract the hours. Okay, so now let's execute this line of code. Okay, so this is returning as a like data series, okay, or Pandas series. So in the left side, this is the index, and the right side is the hour. Okay, like there are total 24 hours in a day, so these hours are the values. Okay, in this Pandas series. So I'm going to simply add a column and store these values into this column. Okay, like let's say I'm going to create all underscore data hour, and I'm going to store the panda series into this column. Okay, so now again execute this line of code. Okay, so now we are going to group the data by hour to count the number of the orders made at each hour of the day. So let's apply group by dot group by group by hour. Okay, let's see what this line of code returns. So this is not returning as the actual data frame. Okay, no problem. uh, to access this to access our data frame or the actual output, let's run a for loop. Like actually this line of code must return uh, actually this line of code will return two uh, values. Okay, one is the key, that means one is the total unique hour of a day. Like there are 24 hours, as we know there are 24 hours in a day. Okay, so this will return the hours, and the second value will return the count of the uh, number of orders made at each hour of the day. Okay, by applying this group by function. So I will apply a for loop for e, then our data frame in this group by, and then I'm going to print e, and then I'm going to print our df. Okay, now let's see. So this at the left side, at the most left side, this is the index, and then this is order id. So if we look at this output, we can see that every in every portion, okay, there are at the rightmost there are column hour, and where uh, there are same column or same the value with same hour. Okay, like 00 every. Okay, so and this is there is our one. So similarly, like this there will be total 24 hours. Okay, so now uh, we can create a list of uh, keys and initialize it by empty list, and then I'll create another list and initializes this okay, as empty list. Okay, now what I'm going to do is I'm going to keys dot append key, and then our dot append length of hour, because here we are going to uh, sorry, our df, our underscore data frame. Okay, because here we are going to count the number of total orders. Okay, uh, made at each hour of the day. Okay, now execute this line of code, and so now this is visualization time. Now let's uh, plot a grid. I'm going to use a grid here. So, and I'm going to plot my visualization or visual in this grid, like plt dot plot. I'm going to put key in x-axis and the hour in y-axis. So now let's see. We're getting an error. This is saying that a value error, x and y must have the same first dimension but have shapes 1 and 24. Okay, sorry, I need to keys here. Okay, the list. Okay, keys. So again execute this line of code, and we're getting this visualization. So we can get our solution of this objective, like what time is the perfect time, or what time we should display advertisement to maximize product purchase. Okay, so we can find the solution by analyzing this visualization. How we can see that this around 12 to 15 hours. Okay, the product purchase or the number of count of number of orders is maximized or peak value. Okay, there are two peak values. One is between 10 to 15 hours and another one is 15 to 20 hours. So uh, in x-axis, let me give it a label to for better understanding purpose. X label. This X label is showing uh, hours. Uh, okay, and Y label is showing the product purchase. Product purchase. Okay. So uh, we can say that between, let's say, this before this hour, uh, let's say this point is 12 hour. Okay, this 12 p.m. So between 12 p.m. and let's say this is 18 p.m. Okay, or if we convert it into like, we can say from this visualization, after analyzing it, between 12 p.m. and 8 p.m. or in 12 p.m. and 8 p.m. is the uh, perfect time. And for better visualizing purpose, we can also expand the x-axis like x ticks, and I'm going to give like hours. Okay, or keys, sorry, keys. Okay, so now this will be more efficient or easy for us to visualize or analyze this uh, plot. Okay, so if we zoom this plot, zoom out, so if we zoom in this plot, uh, we can see that there are two peaks. Okay, so these two peaks must be the perfect time for advertisement to get maximized product purchase. So uh, so this hour, like 12 p.m. Okay, so 12 p.m. and this is 19 p.m. or 7 p.m. 19 p.m. is equivalent to 7 p.m. Okay, so these two time, 12 p.m. and 7 p.m. is the perfect time, or is the good time for displaying advertisement to maximize for product purchases. So this is our final outcome or solution. Okay.